Hello everyone, it's August 30th. What do we have? Oh, it's Sudoku Solver.
I say, oh.
Because yesterday is Sudoku Validator. Today is Solver. So I just solve it. I don't have to return anything. Okay. Let me see. Isn't this just... I think it's just brute force. Backtracking. This is 9 by 9. So we'll backtrack. So we just pick a number. Right? And then we'll go to the next one, we pick a number. Go to the next one, we pick a number. And go to the next one, we just every time we just pick a number. And then next one we pick a number. And next one. So every time we will check if this number works. If it works, we move on to the next one. If it doesn't work, we backtrack. Okay, there is a chance that we might run over time. That is definitely likely. But I don't see. There's no strategy. Like what strategy are you talking about? So essentially, we're gonna create state. Okay, we're gonna create a state for each row, create state for each column, and create state for each 3 by 3. And each one of them will be. So it's essentially we're gonna create 3.
You just took the cotton ball. You ran away with the ball.
It's a little bit wet, but.
You stuck down.
This is gonna be. How about I throw him a ball?
Yeah, that's good.
Or maybe we can just give him a cotton ball.
And then he'll eat it.
Oh, he will definitely. He smelled the ball and he's not interested. I think because the cotton ball also smells differently.
Well, put them in the washing machine.
He's coming, Lord, he's coming.
But now I'm using it.
Okay, that's fine.
Or will I give him one?
No, I think he'll definitely eat it. He will use his front paw to hold it down and then lick it. And then it will all be licked off.
You gave him the ball?
I gave him the ball, but he's not interested. Alright, backtrack it is. Let's try backtracking. Yeah, I was thinking, do we need DP? Like, what type of DP are you thinking about? I don't think DP will work though. How would DP work? No, we're just backtracking this. Brute force using backtrack. I don't even want to know what the runtime is. I don't want to know. Okay, so essentially every time we go, we have an ij, and then we need to backtrack. So I need a separate function, which is void backtrack. We're gonna pass, ij into it. Right? So what we do? Maybe it's easier to use lambda. Okay, how do I define lambda? That's a good question. I forgot. C++ define lambda. You kidding me? Where is the AI? Oh, I'm in AI mode. Capture clause, parameter, return type, function body. Okay. Capture. Do we even need to capture? I guess we need to capture. Capture by value. Capture by reference. I guess we can just capture by reference, right? Yeah. Okay. Alright. So what we need is of Boolean value. Row. Right? So I have 9 rows. Each row have 10 values actually. It's 10 values. And we do the same thing, but instead of row, this is column, this is inner. Okay, so that is the 3 we have. And then we'll define, we say capture by reference and int I, int j. I think I need to say auto backtrack. Right, that's how we define it. Yeah. Okay, so now I have ij, we have board. Now what? So for each one I am at here, I want to know what I can do. So I have 9 choices. Right, I have 9 choices. So I say for int value equal to 1, value small equal to 9. V++, right? For this, I need to check. Right, I need to check. So we say check row is if row I, V is true, which means it has seen before, we'll continue. If column J, V, we'll continue. Right? And int I is equal to I divided by 3 multiplied by 3 plus j divided by 3, right? If inner I, v continue. Okay? And yeah, we'll continue. So if go through all 3, they're all good. So which means the current v satisfies, then we'll say board ij. Oh, that's actually, yes, board ij equal to v plus 0. Maybe I say static cast char v plus 0. Okay, and then we should say solve. Oh, this, I think this should be Boolean value. Right, so we set it to this, and then I say row I, v, true, column j, v, true, inner IIV true, right? So we set those three true. Then we call this, and we say, we call this if. Hold a second. I think you're wrong. This is void. Then we say if backtrack we need some terminating cases, because otherwise I'm gonna go I plus 1, no, ij plus 1. Alright, maybe I need to go I cannot. Can lambda function be be defined recursively? Yes, it can. But I need to give self. Oh, you have to pass it to itself. It has to be C++ 23. I'm not sure if I'm on 23 though. Maybe I'll just use this. This feels the most the simplest way, at least from my use case. So instead of doing auto, I'll say std function. Right, function. I'll pass its type. So it'll be boolean. Return passing int and int. Yeah, then I can do it. So I say if this is true, now we return true. Otherwise, we will try another one. But I need to set all these things to false. Ooh, so I need to go here. Set everybody to false. Wait, hold a second. There are a lot of things I haven't done. Hold on. And here I need to return true. Okay, there are a lot of things I haven't done. For example, when do we decide it's the end? And we always go this, so what we can say is if j is equal to 9, so So j is outside, and I is smaller than 9. So we're going out. Then we will return the next one. We say backtrack I plus 1j. Okay. If I is equal to 9, because I always go this, right? So and j is equal to 9. So both are equal to 9. Then we'll return true, which means in this case we have succeeded, and I will move on to the next one. Right? Move on to the next one. And then the next one is just happen to be. Actually, I would like to put this one first. Return true. Otherwise, return this. Alright? And then we'll try, and then we say if board ij not equal to a dot, then I'll actually compute this one outside. Right? Then we can say row. Ooh. I know what to do. I know what to do. We'll do it beforehand. So if it's not equal, then we will just return the next one. So we don't even do it. Right? We don't even do it. So we just return backtrack I j plus 1. Right? Yeah. This is about how this is gonna go. But before we make the call, we have to go for int I equal to 0 as smaller than 9, plus for int j equal to 0 j smaller than 9, j plus plus. Okay. And we say row I, int v is board ij minus 0. Now v equal to true. Row j, v equal to true. Inner I3 times 3 plus j divided by 3, v equal to true. Right, so we get all these. So by going through this, if board ij equal to dot, continue. So we pre-fill the states, then we go in there and we can skip I can skip all the ones that's already been pre-filled. And we go through this, and let's give it a shot. I think I'm going to give one example. Okay, I don't understand what happened. I didn't feel anything. Okay, this is false. That was an error. Oh, because I didn't call the function. Jeez. Yeah, this is false. Because it goes through everyone and then it's not good. So what we need to do, we'll call the function. We'll call backtrack 0, 0. So here we'll call this function. Okay, now I don't understand. I call the function. Well, it was skip, and this one will be the first one. Dude, what happened? I have no idea. Oh, here. I think it should be 0. It should be 0. I think time to debug. I don't know what happened. I honestly have no idea. Okay, yeah, this is wrong. This should be 0. How do I debug this? Oh my lord. Cool. Okay, so we'll put the breakpoint here. This is 31. Oh, shh. My bad. Huh. Well, there's no C out in this case. Okay. This is bored, we don't care. Row. I just want to see the first row. True, 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 false. Okay, what the hell is that? Zero to 9. 0, 1, 2, 3. 3? How come 4? I don't understand. I don't understand. I haven't called backtrack, right? Yeah, I don't think I called backtrack yet. We're going through this. So I 0. We have 3. Where does the 4 come from? What the hell? Okay. We're talking about the first one is 5, so no. V is 5. So row 5. Okay, row 0, 5. J is the first column. Oh. We have a typo. Huh. What value is that? Nine zero. Okay, so on here, then we go 9-0. So yeah, we have 8. We're at 8-8, which is good. We go to 9-8. No. 8-9. We go to 8-9. We go here. That means we're done. So okay, yeah. Yep. Oh, let's pray that it will not time out. Oh yay! We didn't time out. We did not time out. We did, however, use debugger. It's just some issue. It's not as smooth. All right, it's not as smooth. Yep. Right afterwards. And the second time I done is I used C++ back then. Ooh, priority. What the? What? Oh. Instead of using a vector, you use you can use a vector. Which one gets checked? So we can improve on the speed by using a vector. Everybody is like, if it's seen and it's set. Okay, so same solution, but with bit mask. Then it's going to be an integer. Right, and this is going to be integer. This is going to be 9. This is going to be an integer. This is going to be 9. Mask. Right, and then it's gonna be this equal to mask. So we have this, we say mask, right? And mask if, yeah, that means if means it has been filled already. here, do I. Alright, how do we set it to false? So basically, I set it to 1. Now I need to set this to 0. I'm going to do exclusive OR. Okay. Maybe it's faster, maybe it's not. Actually, I'm not sure. Are we gonna be faster? 119, which is slightly faster. I'm not gonna read this. You're kidding me? I even use a template. I have no idea why I do that. I feel like this is just, I don't know, what's the number of test cases we run this time? 7. Back then it's 6. I think it's essentially the same. I think this is just, it's just backtracking. I don't see anything more. What the hell? What the actual hell back then? You know what? This is definitely an improvement. Right? This is definitely an improvement compared to before. Unless we have some secret sauce that I didn't know. Because back then, this one is pretty fast. It's like scores 0 millisecond. But we use priority queue. I don't understand. And then, and queue itself is not priority queue though. I have to set up a cell. And a set up constraint. What the hell? Nah, I am not going to be bothered by this. This is my solution. Brute force. Brute force. It says everyone will find a solution, so we don't have to worry.